Hey guys, we have a couple more vocabulary words that we're going to add into our vocabulary. So nothing brand new on the concept, just a different way to say it. Okay, the first one is a functional relationship. What is a functional relationship? So you might be asked, does this data, given some things, have a functional relationship? And you know that it has a functional relationship that if every independent variable, there's only one dependent variable. Okay, so Nathan can only have one height, and Sam can only have one height, and Abby can only have one height. So then therefore this is a functional relationship because we have our independent variable, which is Sam, Abby, and Nathan, and our dependent variable is their height. Okay, so there's only one of each of them. So then yes, it is a functional relationship. It's just another way of saying, is something a function or not? Okay, so you look at something, you decide whether it's a function or not. You can also say that this has a functional relationship. Okay, same thing here. It's another word for whether something is a function or not. What has one-to-one correspondence? And it's the same idea. Only one x is paired with one y. Okay, so like we said, there's only one domain for each range. Okay, so I have two examples up here. This one right here, we have 4 goes to 3, 5 goes to 2, and 9 goes to 1. Those all have a one-to-one correspondence because only one x is paired up with one y. This example here, we have 3 with 7, 3 with 10, and 6 with 7. This is not a function, or it does not have one-to-one correspondence because one x is not paired up with one y. We have an x paired up with two y's, okay? So this is not a one-to-one correspondence. So these two words, just new vocabulary words for saying the same things as is something a function or not. So functional relationship and one-to-one correspondence. Okay, brand new concept. We know the vocabulary for what an independent and dependent variable is. Now we have to be able to look at it in a sentence form and decide what is the independent variable and what is the dependent variable. Typically what I like to do is read through the sentence first and ask myself, what depends on another? So what thing depends on something? And that immediately gives me my dependent variable, and then the other one is the independent variable, okay? So in general, the average price of gas slowly and steadily increases through the year, okay? So what depends on something? The gas depends on the year, okay? So that makes, or the time, okay? So it's going to go up slowly and steadily over time, so it's depending on what time of year it is. So that makes the price of gas the dependent variable and the year or the time the independent variable. Okay, so you can write it in any kind of form. You can say that your independent variable is time, and that's also your x value, right? And then your y value or your dependent variable is your price of gas. Okay, so I have two examples here. I'm going to walk you through them. You can pause them and do them on your own and then check your work. The first example, the distance a person runs increases with time. Okay, so the distance a person runs increases with time. We're going to ask ourselves, which one is dependent on the other? Okay, the distance is depending on the time, okay, because if we slow down the time, the distance will slow down, okay? So typically, time is always your independent variable, okay? So our x variable, which is independent, is time. And distance, okay, depends on how much time we're running to decide what our dependent variable is, or our distance. Okay? Last one. As the dimensions of the square decrease, so does the area. As the dimensions of the square decrease, so does the area. Okay, So what we're asking ourselves, which one is dependent on the other? Okay, the dimensions decrease and change. Okay, the area depends on the dimensions. Okay, so the area is whatever the dimension is, we calculate the area from it. Okay, so our dimension is going to be our independent variable. So area is our dependent variable. So our y value, our dependent variable, is the area of the square, and the x value is the independent variable, and that is the dimensions. Okay, so the dimensions are independent. You can change them up, but that's going to ultimately change up the area also.